Modern knowledge workers are surrounded by brilliant tools, but those tools live in entirely separate, disconnected environments. This setup creates a constant bottleneck. The human worker is forced to act as a manual bridge, continually copying and translating context between an AI chat window and their project management boards. It limits how effective a digital assistant can be. Right now, most AI operates like an isolated intern, with zero native access to the team's ongoing tools or project history. This animation illustrates the core pivot of MoodLens. By taking the standard human workspace, Kanban boards, sprints, and docs, and combining it with a layered AI workforce, scattered workflows snap into one unified hub. When AI exists outside the workflow, the time saved on generating ideas is often lost to the manual effort of moving that data back into the team's actual operating layer. That hybrid layer starts with a shared workspace, where human teams actually plan their day. Operating this space is a generalist AI named Moody. Moody maintains full, continuous visibility over the team's calendars, backlogs, and documents. Look at this centralized dashboard. Issue a natural language command in the chat feed, and Moody immediately translates messy notes into structured, prioritized Kanban tasks. Its primary function is keeping the workspace organized and automatically surfacing the next steps, ensuring the human team never loses context. Establishing a centralized AI generalist reduces the administrative tax of manually managing a project board, leaving the human team to focus on the work itself. A generalist assistant is excellent for daily triage, but eventually the team hits a highly specialized or complex operational roadblock. That requires the second layer, AI employees. These are role-based specialists, like finance, legal, or tech build, equipped with specific knowledge templates for their discipline. They collaborate through team discussions, which operate as shared workspace threads rather than isolated one-on-one chats. This setup allows a human to prompt multiple AI specialists at once. As you can see in this data flow, they debate, cross-reference, and gather varied perspectives together on a single document. Delegating work in this shared environment ensures the status of complex tasks remains entirely visible to the rest of the team. Real problem-solving requires a multi-agent environment where specialized AI roles can actively collaborate with each other and their human counterparts. How does a solution developed in a team discussion graduate from a conversation into independent execution? This happens in the repeat and scale phase, where stable patterns turn into scheduled, event-driven automations. The infrastructural barrier to AI autonomy is security. Instead of dangerously exposing raw credentials and prompts, MoodLens filters permissions through secure workspace secrets. AI uses these to autonomously push active updates to live lanes like GitHub. Proven routines then package into reusable system packs. This external action layer extends beyond the platform itself. It connects out into messaging apps like Telegram and Slack, preventing specialist work from getting trapped inside a browser. Providing AI with secure, credentialed operating lanes transforms a conversational assistant into an agent capable of manipulating external engineering systems. Zooming out, we observe the MoodLens ecosystem operating at once. Humans set the strategy, Moody controls the workspace, and AI employees execute outbound tasks. This architecture moves the human user away from manual data entry and towards the oversight of these interconnected agents. This active, live engineering environment replaces legacy software that relies heavily on static imports and fake ongoing syncs. By layering humans and AI within a single operating system, the focus moves from individual model intelligence to the collective execution of the entire team.